Okay guys, we're going to finish our discussion on reactions with alcohols. And when we last met, we were talking about the reaction of an alcohol, in our example here, in propanol, with sulfuric acid. Now, we said that depending on the temperature of the sulfuric acid, we may get something completely unexpected. Up to now, we know that when sulfuric acid reacts with an alcohol, one of the protons from the sulfuric acid is going to protonate our alcohol. Like so. So there's our protonated alcohol. Now, during the reaction, obviously you're going to get as a byproduct the conjugate base of sulfuric acid, which is the bisulfate anion. Well, the bisulfate anion acts as a true base in that it's going to take a proton away from the alcohol and thereby force out water. Hence the term dehydration. And we come away with an alkene. Now, we said that this reaction typically occurs at about 200 degrees Celsius. Now, question is, what happens if the temperature is a little less? So, let's play around with that and see what we come up with. So I'm going to take the same in propanol, and we know it's already been protonated, so I'm not going to go through the bit with the sulfuric acid. I just want to show you the protonated alcohol again. Now, here's the catch. If we assume that we have an excess of the N-propanol, so here's our second mole of N-propanol. The N-propanol, well, the additional N-propanol, has the ability to act as a nucleophile and attack this primary carbon and force out water. So you're still losing water, so there's still an element of dehydration present. But instead of coming away with an alkene, you're coming away with an ether, or in this case, a protonated ether. Now, for the most part, again, assuming we have an excess of alcohol present, we need something to act as a relatively weak base. We can use some of that excess propanol that we've been talking about. And we can essentially get rid of that proton to form our ether. So this is a proper ether. Now we're going to talk more about ethers in the next video. But this is what we expect to see. Okay? Now, I guess the obvious question is, does it matter what kind of alcohol that you use in order to make an ether? In this case, we used a primary alcohol in the form of N-propanol. But does it really matter? And the answer is absolutely. So, in order for two alcohols to form an ether, I need a strong acid catalyst such as sulfuric acid or phosphoric acid. I also need lower temperature. Now, when we had the dehydration, we were running the reaction at approximately 200 degrees C. If we lower the temperature to, let's say, somewhere between 140 and 160, we will get an ether. Now, the alcohols themselves have to be primary. Well, why do the alcohols have to be primary? Well, if you recall the discussion that we had on nucleophilic substitution, whenever you have a primary alcohol or primary alkyl halide, the reactions favored tend to be nucleophilic substitution. Secondary and tertiary substrates tend to favor elimination type reactions. So again, in this particular case where we are talking about alcohols, the alcohols themselves have to be primary in order to form an ether. So, take home message: primary alcohol, lower temperature. Alright guys, thank you for your attention, and we are now done with our discussion on alcohols.